I'm now the community champion at StreamSets. I've been there for just coming up to 18 months. So community champion means that I look after our open source community. I write code, I write tutorials, I blog, I tweet. I'm just generally, I always say I'm not an engineer, I just play one on Twitter. And if you want, you can fuel my personality cult by following me on Twitter at Metadaddy, which is in 4 locations around the room. This is incredible. So yeah, prior to StreamSets, I was a Salesforce developer evangelist for 5.5 years, which was an awesome gig. It really was a great place to be. So what am I going to be talking about? So I'm going to give you a little bit of introduction to StreamSets and what we do and some of the core problems we were founded to solve. I'm not going to spend too long on the slides because I really want to get into the technology. And I'm going to explain how I built this integration. So I'm reading data from Salesforce, reading cases and opportunities, and writing them to Neo4j, so a graph database. So unlike Salesforce or Oracle or MySQL that are very much oriented in terms of rows and columns, Neo4j works with nodes and edges. So we'll have a look at that and what that gives us. And I'm by no means a Neo4j expert. There are Neo4j experts in the room. Ryan, look up. Smile. And they can tell you much more about Neo4j, but I can give you a taste of the kind of visualization and analysis that you can do. And if you want to know more, then I'm sure Ryan and Karen as well will be able to tell you. So has anybody here heard of StreamSets before they came to this meetup? Okay. Oh, wow. Okay. Anybody using StreamSets? Not yet. Okay. So StreamSets was founded by 2 guys about 3 years ago. One of them had been at Informatica. In fact, he was the chief product officer at Informatica, which is probably a familiar name to a lot of people in the Salesforce ecosystem. They do a lot of tooling for Salesforce. Our other co-founder had been at both Informatica and Cloudera. So one of the big Hadoop vendors working in big data. And what they had realized in those positions was that the existing ETL tools did not work well in today's world of streaming data and big data. And by big data, I mean data that is too big to fit on a single machine, where you have to have a cluster of machines managing your database. So terabytes or petabytes of data. So they founded StreamSets, and StreamSets really brings together a lot of people who've spent a lot of time in different companies. So I was at Salesforce for 5.5 years. We have people from Elastic, Square, Facebook, Mapr, one of the other big data vendors. And we have a number of Apache committers and project management chairs. So we have this strong big data open source ethos. So we've grown over the past 3 years or so. We now have customers across a whole number of different verticals, and we partner with some of the biggest names in cloud and big data. And as I mentioned, open source, our core product that I'll be using is Apache 2 licensed. You can just go download it, start using it, hook it up to your Salesforce org, not your production org. Hook it up to a DE org while you get the hang of it. We've had, actually this is an old slide, we've had over 250,000 downloads now. And you know, part of my mission is figuring out who's using it. So we think about half of the Fortune 100 have downloaded StreamSets, are using it or evaluating it. And those numbers just keep on going. So I'm not going to like labor these slides. I'm just going to kind of give you a flavor of the kind of problems we solve. So one of the core problems is this idea of data drift, and this is really where traditional ETL tools would get hung up. In the old world, we were working with enterprise databases, data warehouses with fairly static schema. You know, there was a change process for adding a column to a database, and things worked pretty well. Nowadays, we're in the era of big data and fast data, and things are changing constantly. And we know this, like working with Salesforce. You get a request to add a field to a custom object, and you can just go do it and test it and deploy it, and it's there. And anybody downstream has to kind of cope with this. So we've seen kind of three flavors of data drift. Structure drift is the easiest one to understand. So I add a column to my table, add a new table, something changes, and if you're lucky, your synchronization ETL process breaks, and you know about it and you can fix it. If you're unlucky, then that data just does not flow, and analysts carry on making with their analysis and making assumptions based on incomplete data. Semantic drift is a little bit more insidious. It's where the structure of the database isn't changed, but the meaning of the data has. So for example, maybe up till now you've had 5-digit US zip codes in your zip code or postal code field, and now you have international customers, you have Canadian postal codes which are alphanumeric. How many of those downstream tasks are making assumptions about 5 digits? And finally, infrastructure drift is when we're using a lot of tools and upstream infrastructure like web servers and firewalls that nowadays we ingest those logs for analysis because we can do things like ingest CDN, content delivery network logs, to see who and where are downloading our data. So maybe downloading binaries we want to do some analysis on, where they're being downloaded from. Well, the CDN network's making changes all the time. You install a new firewall, that log can change. So that's the infrastructure drift that again can just break your processes. So I'm not going to spend much time on it. So where we fit is in this reading data from logs, devices, streams, applications, and rather than having this schema-driven approach of, okay, I've got to define how everything is on the input and how everything is on the output, we have an intent-driven approach which says, okay, I want to bring everything across. I need to look at these fields to make a decision whether to filter it out or whatever. But for the most part, I just want the data to keep flowing as things change. Just bring everything that's over there into my Cassandra or Hadoop or wherever, because I want it to keep flowing. I don't have time for this to stop and have to fix it. So one example that we actually saw with a customer one time was they were reading in IP addresses, records from their data centers with IP addresses, and one of their data centers upgraded to IPv6. And the result was that data, those IPv6 addresses, look nothing like a traditional IPv4, dotted, what are they called? Dotted quads? I can't remember. Anyway, 206.192.36.45. The IPv6 addresses are completely different. They were just getting dropped. And the result was that when they were doing analysis, looking at how many of these IP addresses there were and so on, and their data was now bad. Their rows were missing IP addresses. They were doing analysis on their click-through rate that was now based on faulty data. This stuff was just silently being dropped on the floor. And industry analysts, estimate that data analysts spend about 4/5 of their time just preparing and gathering and validating data before they could even get to the analysis phase of actually drawing conclusions. So that's why we built StreamSets Data Collector, and you can think of it as it's almost like an IDE for building these data pipelines. You've got data being produced somewhere, so it could be log files, it could be a transactional database, it could be Salesforce. You want to pick it up. Typically, you want to do some transformations, and then you want to write it somewhere. So you could be writing it to Hadoop, you could be writing it to Einstein Analytics, you could be writing it to Neo4j. And it's really a general purpose tool to design these data flows, these pipelines, and then to run them. Now, some of our customers have literally thousands of these data pipelines. We have a major pharmaceutical company as a customer. Pharmaceuticals is a very data-intensive industry, and we built this tool, Data Flow Performance Manager. So if I go back, so this is a data flow, a pipeline reading from FTP, and it's doing some decision there, this selector thing sending records along one of three paths. So they're going to a high priority Kafka queue, a low priority queue, and a Hadoop file system. So that's one pipeline. Typically, these things feed each other. So I might be reading from FTP, feeding Kafka, the message queue, and which another pipeline reads from there. So in here, each of those like green boxes with the gear is one pipeline. So we can get an end-to-end view of data flowing across the enterprise. And this is our vision of data operations, having a handle on where the data is moving around. Anyway, I don't need the conclusion. Oops, what the heck? Okay, this is where I go to the demo. All right, I have done this before, it's okay. So let's start with reading some data from Salesforce. So I have a completely vanilla DE org. Let me, how's that? Oh, that's looking pretty good. Okay, so what I've done is I've created a very, very simple pipeline. So I'm going to be reading data from Salesforce. Now, to avoid sharing my credentials with 50 of my closest friends, I'm loading them from files. This is a DE org, so I'm authenticating against login.salesforce.com. And what I want to do is both query some data that's there and also subscribe for updates as data changes. So the query I'm doing is actually, let's just do select ID, comma, name. So I'm selecting ID and name from case. So just getting some case data. And you'll notice that I can use the bulk or the SOAP API. So bulk API is really good for huge amounts of data, but it's asynchronous. I issue a query and it kind of can take some time to get back to me. And it's worth it if you're working with like hundreds of thousands of records. But the SOAP API is a little bit more immediate for kind of interactive use. Works really well here with the scale of data. And I've got this query that I've structured this so that basically if something happens and the pipeline stops, I can pick up from this offset where I last was looking at it. So just explaining that. And I'm going to be subscribing to the streaming API, this case updates. Okay, so let's have a look at how this is going to work. So I'm going to preview this pipeline. So what this does is it goes to Salesforce and just gets 10 records so that I can get a feel for what's going on. And I just screwed something. Oh, cases don't have names. A whole room full of Salesforce people, and nobody said, dude, cases don't have names. What is it, case number? Subject, maybe? I've done that so many times. All right, so let me just zoom in on this. So I got my 10 records back, and this is really nice now because I can start to introspect my data a little bit. Remember I said this is like an IDE? I can write a query and I get back a record ID, and I can see that that field has length 18, so I'm getting all the metadata. Case number is a string of length 30. So I can start to play around with this. I can start to kind of say, okay, I think I'm getting back something that looks good. One of the nice things I can do, this always really bugged me when I worked at Salesforce. I can do this. Because what I do is I read the metadata, and then I get back everything that you have access to. So I can see everything on the case. And I can also do fun things like, so just because I can basically do any SOCL. So I could do, say, select ID, comma, account dot name. Let's have a look at that. I can follow the relationships. So I can have all manner of fun here. But the thing I really like about this is that I'm kind of in this preview mode. So I can see the data that's coming back. I can see this kind of hierarchical structure. Here I've got the record with the account that has a name. So I've got like 2 levels of hierarchy. I'm not writing anything anywhere yet. I'm still in this preview mode. So I'm still like just playing with the data source and retrieving it. So the next thing I'm doing here is I'm evaluating an expression. So what happens is when we start receiving updates from the streaming API, this Salesforce CDC type will be created or updated or deleted. And I want to move that into an actual field in the record so I can see it more easily, and then write the whole thing to the local file system. So I'm just going to start dropping files into my temporary directory with a timestamp so I can see what's going on. So let's read some data. So if I reset the origin, let's change the query, make it select ID. What do we want? Case number, subject, and account.name. All right, so if we reset already, so if we start it, so what it's going to do, and this is a DE org, so there's not a huge amount of data here, but it's going to go and get like the 26 cases that are there, and it's written them somewhere. So if we go, yep. So we go to temp out ls cd 2017-08 20, and it's in English time because why not? So I've got a file there, and if we do tail -f, so that's the last few cases in our file. And you can see I'm writing it in JSON format. I could have written it in CSV or JSON or Avro or any of a number of formats, but I just chose JSON because it's fairly self-describing and human readable. And you can see there we've got the ID, the case number, and again we have this hierarchical structure just as it's coming back from Salesforce with the account name. So let's go in and mess with something. So I know case is a Service Cloud thing, but I'm used to using Sales Cloud. So cases, and now if we change this thing and say, okay, we thought this case was closed, but you know what? It's not quite working anymore. What should happen, go here really quickly, that should go to 27. And then over on our text file, we've got the changed record. So happens I've set up the push topic to give me all of the data when anything changes. So you can see in here it says that SFDC operation is updated, and then it's got the status should be there as working. There it is. So status is working. So this is really nice, and we can build these pipelines. We could also write data to Salesforce, but what I'm going to do now is look at Neo4j. So again, very, very simple pipeline, because what I want to do is I want to read all of those cases from Salesforce. and I want to write them to Neo4j. And then I also want to read the opportunities and write them as well, plus all of the accounts, contacts, and products to give us a graphical view of the state of our company. So what I'm doing here is I'm getting much more. So I'm getting, let's see, actually it's probably big enough. I'm getting all the account ID, the name, the contact data, the product, all of that I'm going to put into Neo4j. Now, I need to decide whether or not this is a new record or an updated record, because I need to do things a little bit differently in Neo4j. Now, the key to doing this, and one of the reasons I kind of got this all working was we can write to any JDBC data source. So JDBC is like the Java database connectivity. It's a way of getting data in and out of just about anywhere. And Neo4j has a driver that supports this. So I didn't have to write any Neo4j custom code. I just said, okay, I'm going to use JDBC. I'm going to load this Neo4j driver. And it says SQL query, but actually, this isn't really SQL. Neo4j uses a language called Cypher to manipulate a graph. And so what I'm doing here is saying, okay, for every case, I want to merge this into the graph, and it's going to be identified by the case ID. And then I want to set all these attributes on each case. And then I want to do the same thing with the associated account. And so basically, this is creating a bunch of nodes in my graph. And once all these nodes are created, I can start associating them. So I say, okay, this case is associated with this account. It's associated with a contact. The account is the parent of the contact. So I can build up this thing. So it's probably just easiest just to show you this in action now. So here's Neo4j. Right now, if I go to my little cheat sheet, I should have an empty database here. All right, so I've got nothing in my database. So if I go and run this thing here, so this is where I kind of cross fingers. Whoops. And remember that I need to reset it. So one of the features of StreamSets is it's a continuous system. So once we've read some data in, we keep track of what we've read in. So if you run the pipeline again, it's not going to read anything because nothing's changed. So what I need to do is reset the origin here, throw away that kind of cursor, that marker for the last thing I was reading, and press play. And now, this time, yay! So we've read our 26 records in, we've written them to Neo4j, and now over here, if I go in, I can see I've got a graph. And this is really nice now because this is the feature of a graph database rather than like rows and columns, is that I can start to navigate this and see the connections between different entities. So all my accounts are purple, and my cases are green, contacts are red, products are kind of orangey yellow, and I can immediately see kind of where the busy spots are. Like I can immediately see United Oil and Gas has a bunch of cases open, and I can kind of see that there are active contacts, and I can start making queries. Now, not only can I, in Neo4j, I can move around and look at this graph, I can actually run queries and do things like, okay, paste this in. I want to see all the cases that have the new status and their associated accounts. And this is a Cypher query that does this. So I want to, and it's reasonably self-explanatory. I want to match cases that are associated with accounts where the case status is new, and I want the case, the relationship, and the account. So if we do this, this gives me like a subgraph. This gives me a portion of that graph so that I can look at this and see, oh, so GenePoint has one new case, and United Oil and Gas have 2 new cases. And I could get this more tabular view, but I don't know, that's really boring compared to nodes and edges and so on. So I can do other fun things. I can say, get some more quantitative data. So I can say, okay, give me cases and accounts where the status is closed, and I want the number of cases like in an ordered list. So this isn't that useful here. It's just like 9 disconnected accounts. But I can see that United Oil and Gas has 5 closed cases, and Grand Hotels has 4, and so on. So I can start to query the data, manipulate it, and so on. And do I have another one here? Oh yeah, I can see, okay, let's look at from the product side. Let's see what products have a load of cases. You know, maybe I've got problematic products. Well, they've all got, each of those 4 has got 1 case open, so that doesn't seem like it's going to be a big deal. Now, the really, really cool thing I can do is I can make changes in Salesforce now. So maybe, let's go to Neo4j and run one of those queries again and see how many we've got. So maybe accounts with the number of closed cases. So if we do that one. All right, so United Oil and Gas has got 5 closed cases. So what we can do is go over here and let's see, let's go from accounts. Just show me everything. You can go United Oil and Gas, and where's its cases? And let's see, let's go mess with it. Okay, let's reopen this case. Okay, now remember, we're subscribed with the streaming API. This should go from 26 to 27. It gets written into Neo4j, and then we should be able to just hit up arrow. I run that same one again, and now United Oil and Gas has 4 closed cases. So we can keep the data fresh on the analysis side. So every query we run in Neo4j is working on fresh data. Now, the other really cool thing we can do, so we've got the accounts there, and you know, as anybody working in Salesforce knows, but to explain to everybody else, Salesforce, you know, at its core, the core product is called Sales Cloud, and it's a way of managing the companies you're doing business with, the contacts you have at those companies, the deals that you have ongoing with those potential customers, as well as support cases and so on. So this concept of an account is central to Salesforce. It's like where that sales data and the service data kind of come together. So what I can do is, oh, and by the way, I should have said this at the beginning, any questions, feel free to jump in, because we've got a lot of concepts going on here. I've got another pipeline where I'm reading the opportunities. So again, I'm reading account ID and account name. And again, I'm creating everything in Neo4j. But the beauty of this merge operation is that if I read the same account in, the same account ID in again, it doesn't create another node. It just uses that existing one. So I'm going to get a connection to an existing account rather than just having a load of duplicates. So I can run this pipeline with the opportunities, and I've probably forgotten to reset it, which is what I always do. Okay, always reset the pipeline if you're doing demos. Don't do it in production because then you get duplicate records. Okay, so this is going to read in my opportunities. So again, I should have a couple of dozen, okay, 31 opportunities read in. And now the really neat thing is if I go to just get the whole, everything in the database. And a graph. So now I see I've got these gray opportunities as well as the cases. If I kind of zoom out a bit, kind of get the big picture, I can see again, United Oil and Gas has a bunch of activity around it. I've got some other customers. But interestingly, I can easily see I've got these disconnected islands. I've got these accounts that have got opportunities, but no support cases. So these are my new customers. So again, the shape of my data is very apparent from this kind of graph view of it. I've got another one down here. So a couple of customers there that have got opportunities. And in this case, I brought together data from the two sides of Salesforce. Okay, so I could do this kind of analysis that I'm doing in Neo4j. I could do with SQL queries if I really wanted to. I couldn't get this nice graphical view. But the really nice thing about this kind of integration with, say, StreamSets or other tools is I could have brought in data from Zendesk or any other system. As long as I've got some correlation, I can start to merge it all together in Neo4j and do this kind of analysis. And the same thing's true if you're doing analysis in Cassandra or Hadoop or any other system. You can start to join data from very different sources and get the bigger picture. So here we've got this idea of the sales data in these opportunities and the service data in these cases, and then we can start to do things like so this is a really nice one. This is kind of where I've been going with this. So if we go away from there. So I want to get cases, accounts, and opportunities. I want to get all the cases that are not closed. So all the open support cases in the company. And I also want to get the sum of the expected revenue for the opportunities. So basically what I'm saying here is I've got a whole bunch of support cases open. I've got customers that I'm working on maybe repeat business with, maybe renewals. And I want to know where's the money? Where are my next deals going to come from? What support cases do those customers have open? Because those are the ones that if I'm going to prioritize, I really want to close those. So those are happy customers. So we have some repeat business. So like this is the kind of query. So United Oil and Gas, they're the big guys in this org. So they've got nearly 8.5 million in expected revenue. So maybe I can go back down here and say, okay, United Oil and Gas, I see these cases here. These are the ones we've got to be prioritizing, and I can have my support team working with my sales team to actually close those down and bring in the revenue. So that's the idea of joining this data from different places. So if we go back to the slides. So yeah, StreamSets Data Collector, as I mentioned, it's an open source tool. It's free to download. We've got, you can go to streamsets.com/community. We have a Google group and a Slack channel. And we really, my job is to make sure everybody in the community has what they need to get going and start working. We have at least 2 customers in production with the Salesforce connectors. One company in education in New York and one insurance company in Europe. So this is production stuff. The one in Europe are using, they're actually reading cases from Salesforce and building an archive in a relational database. So they've got kind of a backup, and they can do some other work in their RDB. And yeah, we can integrate with a whole bunch of data sources, flat files, Kafka, Java message queue, and so on. But really, this JDBC gives us this into almost anything. So we could read data out of Neo4j as easily as we can write it in, and a whole bunch of data sources besides. And yeah, really, I mean, I've only really scratched the surface of Neo4j. I mean, one thing that occurred to me as I was building this is, you know, we're on like a sales and support use case in this example, but you could read in users and chatter messages. So you could start building a graph of who's chatting with who in the organization, and start to see clusters of users talking about particular topics. You can start to say, okay, this user and this user, what's the shortest path between them in people they talk to, and really leverage like the unique capabilities of the graph database. This is what it can allow you to do, this kind of analysis that's just almost impossible with a relational database. But yeah, so Neo4j and graph databases in general offer you a really new way of visualizing data and of building queries and manipulating it. So I'll be really kind of, well, went a little bit faster than an hour, so really happy to answer.
Did you say that you could set up a live data flow to Einstein Analytics to static?
Yeah. The question was, can you set up a live data flow to Einstein Analytics? So the answer is yes. And so fair disclosure here, I wrote the Salesforce integration. I said I'm not a real engineer, I just play one on Twitter, but when I started at StreamSets, they said, hey, you know the Salesforce APIs, you write this stuff. So what I do is, Einstein Analytics, for anybody who hasn't used it, allows you to upload data sets and then perform analysis on those data sets. Now, the thing about those data sets is that once you create them, they're immutable. So I can give Einstein Analytics a bunch of data, and then it's just there, and I can give it another bunch of data, and it's another data set. So what I do is, like my pipelines run continuously. So I have I open a data set and start uploading data to it. And then I can configure a timeout for, okay, after this amount of time, I want to close that data set. And then I start writing another one. But the other thing I can do is I can use a data flow to append those data sets together. So in fact, the appearance that you have is of an ever-growing data set. And I can show you, okay, let's kind of go off without my safety net here. So pipelines, wave. Sorry guys, I haven't redone the branding yet. So this is actually our tutorial pipeline. And so I'm reading CSV data from a local disk. And if I have a quick look at this data, it is a credit card transaction. This is a data set, the New York City taxi data set. And so each record has a medallion number, blah, blah, blah. Payment type is card here, a load of fare amount and so on, pickup and drop off times, and a credit card number. So, and they're fake credit card numbers, don't worry. So what I do is I split the card from the cash transactions. So we can see that this thing is sending anything with payment type card up the top route. Everything else goes along the bottom. So then I've got a bit of Python here that computes the card type. So it's just a little bit of code that looks at this and sees it starts with 4, so it's Visa. This one starts with 51, so it's MasterCard. I mask the card number so that because the card number doesn't need to be in Wave, and I send it to Wave Analytics. So let's run it. So this is where we go off without a safety net because I haven't tried this recently. So reset, run it, and it's got, I think, about 5,000 records, and it's processing them in batches of 1,000. So it's really going quite quickly. This is sample data that I use to demonstrate the fact that we can track errors on a record by record basis. So some of them have payment type card, but no credit card data, so dirty data. And I'm writing them into Wave. And then if I go to my Wave org, and there's a little bit of latency loading data into Wave, so we'll see if it's arrived already. So, sorry, I'm in Einstein Analytics, it's not called Wave anymore. So if I go down, yeah, so I can see that data set. Okay, so here's my 5,000, and I can do, I can demonstrate my prowess at Wave by saying, okay, group by credit card type, and filter, we don't want those not applicable, so filter by, what is it, payment type equals card, so that big not applicable line goes away. And if I could remember how I could order them most to least. That's the one I can never remember. Anyway, so there I can see that my I've got a whole bunch of Visa transactions, but I can also say, okay, what's the biggest average fare by credit card type, and it's JCB, so maybe that's a Japanese one, right? Japanese tourists spend a bunch on taxis. But anyway, so that's those 5,000 records. But also, this tester thing should have run. So hang on, let's refresh here. So I kick off this, I kick off the data flow, and that aggregates them all together. So I've basically got the same data I've processed again and again, but I've got the aggregate here of 37,000 rows because I've run it 7 times. And all I'm doing is I'm manipulating the data flow definition. So I'm writing JSON to say, okay, add this one, add this one, add this one, add this one, so that I give the impression of this ever-growing data set, but it's actually the concatenation of the 7 that I've done so far. Did that answer your question?
Yes, I guess so. I mean, with analytics, you set up your data flow, and then you tell it, okay, every night renew the data flow. So
I'm running on demand here, which you can do, is it more than 24 times a day now?
Yep.
Yeah. So you can actually run the data flow, you can actually trigger a data flow programmatically, and that's exactly what I'm doing. So I upload and I say, run it now, because I want to see that.
And if it takes less than 2 minutes, doesn't count.
Oh yeah, and if it's for this, you can run this all day long, because there's Alex Toussaint, who is the VP of Product Management for Einstein Analytics, says if it takes less than 2 minutes, it doesn't even count towards your limits. Sorry, I'm just having a look at the configuration here. So here we go. Use data flow. So it uses this Sales Edge data flow. All right, another question.
Oh, sorry, this is going to be a follow-on on Wave if we don't
Yeah.
want to go down that path.
No, you're fine.
I
mean, you've got the Wave guys here, so if anything I don't know, they do.
Yeah, I was going to ask how you handle updated records in this concatenation flow.
So yeah, there isn't a good way here. I mean, this is really, you're in a mode where more data is arriving and you're just kind of like building like your data lake or whatever. In the general case, it really depends on the destination. So from a lot of our origins, so say we've got one for Oracle Log Miner, we've got one, the streaming API one. You actually know as you actually get deletes and updates. And if that's the data you're working with, you're probably going to want to use like a data store like for analytics, like maybe Apache Kudu, something like that, that is actually mutable. Because that's the problem people have with, say, Hive, and Einstein has this as well, is that you can start saying, okay, I'm going to rewrite that data because some of it was updated, so I've got to delete the old one and rewrite the new one, and it's like a lot of jumping through hoops. It's possible to do that, but if you're working like with mutable data rather than transactions that are just arriving and more arrive and they don't change after the fact, then you probably want to use a different tool. It's like you can't get there from here. Oh yeah, I'll get to you in a minute, Daniel. Yeah. Question at the back.
Well,
Yeah.
I have two questions.
Sure.
The first one is, can you inject data into Salesforce?
Yeah.
With this method, like
Yep. Do you want to see it?
an XML and then
Yeah. So like just as a fun example, this is actually some functionality I was building in. So I've got a spreadsheet here with, we can see okay. So I've got alternating accounts and contacts and just like dummy name, account number, first name, last name. And I've got a pipeline here. Where is it? Salesforce destination. So I read those in from the disk and I run some Groovy script. And this is just to remove empty fields. Salesforce doesn't like those so much. And then I'm writing them into Salesforce. So if I go to here, so I've hosed myself with multiple logins. 1 second here. So I want to be in my bulk org. Bear with me just 1 second. All right. So if I go here, I should have no new contacts this week. And then I can go and I can run this thing. Probably need to reset the thing. I'll learn one of these days. Yes. Okay. Reset the origin because it knows I've already played with it. Okay, so this should read in 200 records. And it's actually creating them in both accounts and contacts, because what I'm actually doing is saying, okay, in the configuration here, the type of the S object I'm creating is parameterized, so it's coming in from that spreadsheet. And over here, I should have a whole bunch of test contacts. So the really nice thing is, again, this is continuous. So this pipeline's running. So I've processed 200, and if I go over here and say copy my CSV file in the same directory, because it's using a wildcard, it should pick up the new 200. So it's gone to 400 processed, and then over here my org is even more polluted with crappy data. Yeah. But yeah, so yeah, the short answer is yeah, we can write any custom or standard S objects.
I guess you can update.
Yeah.
So the second question is, there's different type of license for Salesforce.
Mm-hmm.
And one is professional, and then the enterprise.
Yep.
The enterprise the professional doesn't let you inject Apex scripts.
You're going to need API access for this.
Just API access.
Yeah.
You don't need to.
We're not running any Apex. All we're doing is using bulk or SOAP API to move data in. So if you've got, does API come with professional, or you can get it as an add-on? I can't remember.
We don't use professionals.
Yeah. Anyway, yeah. If you have API access, this will run. We don't use any Apex at all.
You get API as an add-on, or if you're a partner, you get whitelisted.
Okay. So you can get API as an add-on to professional, or partners can get it whitelisted. So you get it whitelisted with your app. So you,
Become a partner, put them on App Exchange.
Right.
The app can APIs to do
Got it. But, okay, yeah.
So to deploy this into production, I assume we can just spin up a server on some headless server with this?
Yeah, so the question is, to deploy this into production, can I spin this up somewhere? Yeah, so typically, it depends on where your data's coming from. If your data's coming from Salesforce, then you can put it on EC2, somewhere like that. A lot of our customers are working with Hadoop and like on-premise Hadoop, and so that really means like running on the cluster. Now, one thing, did I mention? We can run, so here we're actually running on my laptop, and it's running in what we call standalone mode. So it's just a Java application running on my laptop. It's got a stateless API, which is how we're doing this designer stuff. Everything that I'm doing like through this UI is accessible via the REST API. And it's basically just reading from local disk right into Salesforce, reading from Salesforce right into Neo4j. We can also run on the Hadoop cluster technically as a map-only job in the MapReduce cluster. So if you're reading from Hadoop file system, you get n instances of StreamSets reading in parallel. So we've got a customer which is a non-US government department, and I can't say more than that reads that read 1 billion records out of Hadoop and wrote them to Kudu in an hour and a half. They just put StreamSets. It was running across their cluster, reading the data from wherever it was. The other mode is you can run on Spark with Yarn or Mesos. So if you want to read like high performance reading from Kafka, as many Kafka partitions as you have, that many instances run on your Spark cluster. So this thing scales. Kieran.
Can you talk about the kind of transformations that data transformations do?
All day. Yeah, can I talk about the kind of transformations? In fact, I wrote a blog entry on this, which I will use just because it's got some nice pretty pictures and examples. So the question is what transformations I can do. So this is pretty key because it's a rare day that you have a pipeline as simple as this, even with just getting rid of empty fields. You often have to shred data, spin it around. So in my example here, I'm calling an API, and I'm getting a JSON object that has a results array, and it's got 2 records here. So 2 company records, StreamSets and Salesforce. So what I want to do is pivot that from 1 record into 2. So for every one of those, every member of that array, I want to, whoops, is that getting bigger? I don't know. I want to get 2 actual records. So for every address, I'm pulling them out. And then I want to flatten them down because I've got address with street, city, state, and zip, and that's no good for, say, a relational database. So I want to flatten the record and get, from this hierarchy, I've got it flat now. And then maybe I want to rename some fields because they don't match the columns in the database, and I want to get rid of this address dot stuff and just have street, city, state, and zip. So I can go through a number of stages and then split the street into number and name on a space. So here, 2 Bryant Street goes into 2, and then Bryant Street, 1 Market Street, so on. So I can build these things up and really start to play with this data. These off-the-shelf transformations are very performant because they're just written in Java. So this is like your declarative applications. They perform very well because the underlying system is just Java. You can also drop scripts in. So I had a Groovy script in one of those examples. I could have JavaScript or Python, so Python on the JVM. So you can achieve, and as a test, I tried this out, writing it in Groovy, and it processed 400 and some records per second rather than 500. So you can drop into script, just like you can drop into Apex on what used to be called force.com, and you get a lot of flexibility and power, but it tends to not perform as well as using the built-in tools that tend to be more maintainable. You know, it's easy to get a sense of what's going on by kind of going along this thing, rather than looking at some Groovy that's doing it all mashed together in one, you know, in 6 lines of code. Daniel, sorry, I completely blanked you in favor of Kieran.
Sometimes I hog the questions. So I have 2. The first one's a little bit more of a Neo4j question. When you're visualizing the nodes and the relationships, do you have any control over how those cluster? Because thinking it's doing some nice auto formatting, but
Yeah.
clustering different ways, you could get different insights.
That's probably a question, Ryan. Can you control the way that they get shown?
You can't control the way that they get shown in terms of the clusters in
You
the
can drag them
Neo4j
around.
browser. With the Neo4j browser, you can control like the coloring based off the labels. So based on what type of nodes they are, you can change the colors and the sizes and things like that. In terms of the physics of it, there are other visualization libraries, D3, and then things built on top of D3, which allow you to change some of the physics. In terms of clustering, we do also have a set of algorithms available for Neo4j that allow you to run various different types of clustering algorithms, and then you can feed that to your visualization. But you know, the short end is that this is actually built primarily as a developer interface, what you're seeing here with the Neo4j browser, for kind of the BI interface and things like that. There are third-party tools like Curious. If anyone knows the tool Gephi, the folks that created Gephi, many people use it in academia especially to do graph analysis, created this thing called Curious, which was in Neo4j, and it's a great sort of BI platform that has a little bit more control of that.
That'll be maybe the next blog post. If you're doing chatter data, that would be nice to cluster and label different types of people. And
Yeah, yeah.
my other question was just around licensing and pricing. Is Neo4j open source? Is StreamSets open source? If not, what's the price?
So I can speak for StreamSets. So StreamSets data collector is Apache 2, open source. It's on GitHub. You can download the source and build it. You can download the binaries and use them. There is you know, enterprise licensing and pricing, and talk to our salespeople because they don't let me touch the money. Ryan, do you want to do the same for Neo4j?
So Neo4j is completely open source, but so there's a community edition which is open source under the GPL. The enterprise edition is open source, but is under the AGPL, which is a fairly restricted license. But you know, we do offer enterprise licenses for the enterprise edition. The main difference is operational controls. So like he's using the desktop edition or community edition here for if you want backup and clustering and HA and things like that. That's where the enterprise edition comes into play.
You can do quite a bit with it without paying any money if you don't mind doing all the work yourself.
Yeah.
No support.
Yeah. And the other thing I should mention with StreamSets is, so the data collector is open source. That Dataflow Performance Manager is a service, and that's a paid for. It's like basically a management layer for these things. So it tends to be, if you're into the pipelines enough that you need that, then you tend to be getting value from them, and you know, you're willing to pony up for the management tool. But that really does let you manage hundreds or thousands of pipelines. You could start saying, okay, I've got a pipeline repository, I can see the changes over time, and I can say, okay, deploy this pipeline to those instances. So you can really get like that higher order thing, rather than, you know, the alternative is going to each instance, like with your browser, and having like 10 tabs open and say, start the pipeline, start the pipeline, start the pipeline. You can just do that in like one click in the performance layer. And we've got some sweet things coming down the line with that as well. It's in terms of management and clustering and so on. All right, I think it's a wrap. Well, thank you very much for coming. I totally spaced on bringing swag, but I do have lovely business cards that I'm prepared to give away to anybody that wants them. So thank you.